Hi everyone, welcome to a quick metric units video. This is really important because the metric system is something that we use throughout all of science. Metric system is basically the system that combines the powers of 10 and base units to make relationships between different values. There's an English system which is not used very often because it's sort of weird. It has weird numbers. It's not based off of anything. Like English system is like the foot, the pound, a gallon, right? Like they're just arbitrary numbers. But the metric system is really, really easy because it's based off the powers of 10, which is why everyone around the world uses the metric system. And English system is really only used here in America. So in my videos, I've told you that you do need to memorize and know the metric system and the metric units. I don't like to memorize, you know that, but there are certain things that you do need to know if you're going to be able to do the calculations for the rest of the semester. The metric units are one of those things. So in my video, I said that you need to know several things about one metric unit. So for example, if you look at the table here, we have the first line is a kilo, right? So the SI unit that they're referring to in this example is the kilometer. Well, actually, meter. That's the SI unit. The prefix is what we use to make the relationship between the different powers of 10. So a kilometer is something that is 10 to the third meters. So what you need to know as a student when I say a kilometer, you need to know, first of all, the symbol that's used for that metric unit. So small case m, small case k, small case m. You need to know what power of 10 it is. So a kilometer is 10 to the third power, and the decimal equivalent, which is important for you to be able to do any problems for dimensional analysis. Or conversions for that matter. So again, if I say to you, we're dealing with a microliter, right? Liter is the SI unit, but you can have a microliter, a microgram, a micrometer, just like you see the example at the bottom here. If I tell you that, you need to know, okay, a microliter is 10 to the negative 6 liters. That's what you need to know. If you know that, then you're able to make relationships between the different powers of 10. And that's why this is used all over the world, because it's really, really easy. Okay, so I wanted to just go over some examples before we get to class so you understand what I want you to be able to do when you get to class. Okay, so you see the example here, the first example, which is 1 kilometer is equal to how many meters? The whole thing about metric units is that it's a relationship between 10, right? It's a relationship of 10. So I've always taught my students, when you're going to do these, think of a number line, okay? Think of how many steps it's different between the one example and the other example. For this, I'm actually going to switch over to my OneNote, so I'm going to be able to write on my screen, but I need to put my computer down, so you're not going to see me, but that's okay because I'm still here. So let's go here, and here we are. So for example, that thing that we just saw on the screen said 1 kilometer is equal to how many meters? And like I said, when I do this with my students, I tell them, think of a number line, right? So you have a number line here. Here's your 0. So if you do 1, 2, 3, this would be 10 to the 1, 10 to the 2, and 10 to the 3. This obviously means 10. 10 to the second power means 10 times 10, which is 100. And obviously this is 1,000, okay? If you do it on the other side of 0, it's the same concept. So you would have 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. And obviously you can keep going further down on each side. This would be 10 to the negative 1 is 0.1. This would be 0.01. And this would be easily 0.001. Okay, so the way I teach this to my students at the beginning, because there's many ways to do this, and you get better, obviously, the more you do it. But the way I teach it to my students is start from the small unit. The smallest unit. If you're comparing two metric units, start with the smallest unit, because students tend to think better in positive exponents than they do in negative exponents. So in this example, I've got a meter, which is the base unit, obviously, because it doesn't have a prefix. And then I have a kilometer. So I need to know off the bat, this is where the memorization comes in. I need to know what powers of 10 those two are, and super fast. So I should know that 10 to the kilometer is 10 to the third, and I know that the meter is the base, so it's 10 to the 0, it's just 1. So I need to see how many steps, or what is the relationship between these two units. So if I start here, right, at 0, and I go to a kilometer, which is 10 to the third, which is this one here, I need to move 1, 2, 3 steps. So that means that the relationship between a kilometer and a meter is 10 to the positive third. Another way to look at that is, how many small units do I need to get to a big unit? I need 1,000, or 10 to the third meters, to get to 1 kilometer. And that's why you can put this equal sign here, because that is the relationship between those two units. Let's do another example. So if I have, instead, I wrote 1 milliliter is equal to how many microliters? Okay, so for this to work, again, you have to be able to memorize your units, your metric units, the powers of 10. So right off the bat, you need to know that, let's do this in blue, that this is, milliliter is 10 to the negative 3, and microliter is 10 to the negative 6. So then you ask yourself, who is the smallest one? The smallest one here would obviously be 10 to the negative 6. Then the question becomes, okay, what is the difference between the negative 6 and the bigger unit, the negative 3? So we're assuming that 10 to the negative 6 is in this number line. If you keep going, right, it would be 10 to the negative 4, 10 to the negative 5, 10 to the negative 6. That would be 10 to the negative 6 here. So again, the question is, what is the relationship? How many steps do I have to go from 10 to the negative 6? Let's do this in this color. 10 to the negative 6, right, to 10 to the negative 3. That is 1, 2, 3 spots. So the relationship between a microliter and a milliliter is 10 to the third, 1,000 spots, right? So 10 to the third spots. But how do I know what to put as the exponent? Do I put it negative, or do I make it a 10 to the third, or do I make it a 10 to the negative third? Well, this is why, again, I tell my students start with the small unit, because you always need a positive number of small units to get to a big unit. So I would need, let's go back to my green, I would need 10 to the third, 1,000 microliters, 3 spots, to get to 1 milliliter. I hope that makes sense, because this is really the basis of all of your dimensional, of all your metric unit conversions. And this is what you really, really do need to know, and quickly. So let's do one more example so you can kind of see where this is going. If I had a problem which said I had 2,459 kilometers, and I wanted you to convert that, or tell me how many micrometers that is, right? So now you have to set this up as a problem. So if I would start with 2,459 kilometers, and then I want to convert that, so that means I have to put the kilometer on the bottom and what I want to get to, so this can cancel, right? So this would cancel, kilometer, but then where do I want to get to? I want to get to micrometer, so I would put the micrometer on the top. But then the question becomes, okay, what is the relationship between a micrometer and a kilometer? I would like for you to, in your head, quickly make that number line, right? So you need to know right off the bat that a micrometer is 10 to the negative 6. So that's 1, 2, 3, 4, 5, 6. 10 to the negative 6. A kilometer is 10 to the third, right? So this would be 10 to the third. So how many spots are between 10 to the negative 6 and 10 to the third? Hopefully you quickly notice that it was 1, 2, 3, 4, 5, 6, 7, 8, 9. So the relationship between a micrometer and a kilometer is 10 to the 9 spots, or a billion, right? So you need And how do I know that I put a positive 9? Because I put it always with the smaller unit. The smaller unit always has a positive exponent because you need a positive number of small guys to get to a big guy. So I need 10 to the 9 micrometers to make 1 kilometer. And then you would just put it into your calculator and get your answer. And that's it, ladies and gentlemen. That is really the only thing you need to learn how to do for metric units as far as memorizing them and setting them up in harder examples. All right, I'll see you in class.